Today we're going to be working with this formula up here, the delta Q formula. I often refer to this formula as our specific heat problems because we're going to be using the specific heat uh, of water most of the time when we're solving, unless we're solving for the specific heat of a substance. I will be talking some Greek today. So we'll first start off with looking at our main formula and how you can rearrange and solve for the other letters and what those letters mean. So that's what this video is going to be about, is just breaking down what this all means. The two triangles that you see in the formula um, are delta. So that's Greek for change. So delta Q equals NC delta T. So what does delta Q stand for? Well, delta Q is going to be referring to your change in heat. And Q can be measured in calories. Notice these are small calories, CAL, or joules. When we go to M is going to be mass and it has to be measured in grams. C stands for specific heat. Now, specific heat has the definition is going to be how much heat, calories, is required to raise 1 gram of water by 1 degree Celsius. So it has 3 units in one. Just like density had mass and volume, this has one more in it. And we'll see how they cancel out or they come together to form the specific heat when we're solving. So oftentimes when we're working with the calorimeter, we're measuring the temperature change of the water. So that's why we're using the specific heat of water. And you can either use the 1 calorie over grams times degrees Celsius or the 4.184 joules over grams times degrees Celsius. And again, we'll talk more about this as we start to solve problems. Then we have the delta T, and delta T is going to be your change in temperature, and your temperature is going to be measured in degrees Celsius. So, how to find your change in temperature? It's going to be your final temperature minus your initial or your beginning temperature. So if you're solving for your change in heat, how much energy is being lost or absorbed or taken in during a reaction, you would use this formula here. So delta Q equals mc delta T. So you'd be given your mass and your change in temperature, and you would be told you're working with water. And it would tell you if you're measuring in calories or grams to determine if you're using the 1 calorie or the 4.184 joules. M is going to be your mass. And if you're solving for mass, it's going to be your heat or your delta Q over your specific heat and your change in temperature. I often have students that call this the CAP formula. The delta T, or if you're finding your change in temperature, again, it's going to be your heat or your delta Q over your mass times your specific heat. And that's when you're given your change in heat, your mass, and you're told that you're working with water. And C, this is when you were solving for the specific heat of a substance. So you would be given your heat, you'd be given your mass, you'd be given your change in temperature, and everything would be coming together.